Okay, let's work through an example, first order linear ordinary differential equation using the integrating factor method. Here's my equation. I've identified that it's linear even though it's not in canonical form. It's linear because there's no functions of the dependent variable or the derivative of the dependent variable. My first task is to rearrange this so that it is indeed in the correct form, the canonical form. My next step is to identify my p function. So all the notation can be found in previous videos. And my q function. So now that I've identified my p and my q, I can write down my integrating factor. R of t equals e to the integral of p t dt. Integral of p t dt equals the integral of, or minus the integral of 1 on t dt, which is equal to the minus log of t. Right. Strictly, we've got absolute values in there, but they'll disappear when we take the exponential anyway, so this doesn't actually matter. We now compute R. So that's equal to, what is it? E to the log t minus 1 equals t minus 1. All right, so now we've worked out our integrating factor is t to the power minus 1. We can multiply through, we can take our equation and multiply through by that integrating factor. T minus 1 dy dt, yep, plus, sorry, minus t minus 1 t minus 2, I guess. Just zoom out so you can see the equation. Y equals 1. Right, so that's t on t equals 1. That's nice. We know that this collapses because of the integrating factor. We know that this must be equal to d by dt of integrating factor times y. Once we have this, we can integrate with respect to t. Being mindful to include our constant of integration. And now finally, we rearrange for y. And that's simple in this case, we multiply through by t. So this is our general solution to our linear equation. We see that this solution to the linear equation isn't a straight line. Some people get confused by that. It's not necessarily true. Your solution could look like lots of different things, actually. It depends on the particular value, the particular functional forms of P and Q. Let's just quickly check that this is correct. We check an equation is correct by plugging in the proposed solution. dy dt, differentiate this, equals 2t plus c. Minus 1 on t y is equal to minus t minus c. So dy dt minus 1 on t y is equal to 2t plus c minus t minus c equals t. And indeed, that's true. That's the left-hand side of our, the right-hand side of our equation. That's the left-hand side of our equation. So our solution is indeed correct.